Hi guys, again I am going to explain you a synthesis procedure and MSDS of the synthesis of p-nitroacetanilide from acetanilide. Here is the principle of this synthesis. In the first step of the principle, we electrophilic aromatic substitution of nitronium ion it occurs towards the para position because acetanilide is more works towards the para position than ortho position because of the steric reasons. Nitronium ion is the electrophilic nitronium ion which generates the electrophilic fuming with the nitric acid in the presence of the fuming sulfuric acid. Here is the structural representation of this mechanism. Next step is in this second step, p-nitroaniline is prepared from the p-nitroacetanilide due to the hydrolysis of acetate ion from acetoamide functional group in the presence of the concentrated sulfuric acid. Hydrolysis occurs in the first step, and then it it converts into the acetate ion from acetoamide functional group. Here is the first reaction of this synthesis is acetanilide in the presence of fuming H2SO4 and fuming HNO3 gives the O-nitroacetanilide and p-nitroacetanilide. P-nitroacetanilide is a major product. Second reaction is p-nitroacetanilide in the presence of 70% of the H2SO4 and 10% of NiOH gives the p-nitroaniline. Chemical and apparatus which is used in this synthesis is chemicals are acetanilide, glyceryl acetic acid, concentrated HNO3, concentrated H2SO4, 70% of H2SO4 solution, 10% of NaOH solution. Apparatus are conical flask, beaker, pipette, glass rod and Buchner funnel. Here is the procedure of this synthesis. Preparation of p-nitroacetanilide from acetanilide. Dry acetanilide, 25 gram of dry acetanilide added to glyceryl acetic acid, 25 ml of glyceryl acetic acid in a beaker, and then introduce concentrated sulfuric acid slowly with a constant stirring and obtains a clearer solution. Place beaker in a freezing mixture of ice and salt to cool the solution. This mixture is below 5 degrees Celsius. Add cold mixture of concentrated nitric acid, which is 11 ml of concentrated nitric acid, and concentrated sulfuric acid, 7 ml of concentrated sulfuric acid, which is added drop wise with the constant stirring. Why we do constant stirring is, as I said before in the synthesis procedure, that if we add something so fastly into the solution of whatever the solution we are preparing, so there is a chances of coming of clumps or forms the clumps, and we didn't get a proper proper yield of this synthesis. So this step is really very important step, and temperature maintained till 5 below 5 degrees Celsius. It is also important because we have to freeze this. So after adding all the mixed acid, remove the beaker from freezing mixture and keep it for 1 hour at room temperature. Then pour the reaction mixture into the ice cold water, 30 ml of ice cold water, and obtain the crude product of p-nitroacetanilide. Filter it on a suction with filter it on suction and wash it with the cold water till free from the acids, and recrystallize the pale yellow product from ethanol to get the colorless crystalline solid. Its melting point is 214.5 degrees Celsius. O-nitroacetanilide remains in the filtrate due to its high solubility in water. And step 2 is the preparation of p-nitroaniline from p-nitroacetanilide. Place 30 gram of p-nitroacetanilide and 150 ml of 70% of H2SO4, which is prepared by adding 100 ml of concentrated HCl, 100 ml of concentrated acid to 75 ml of water carefully in a round bottom flask. Then reflux the mixture for 20 to 30 minutes. Pour the hot solution into the 100 ml of cold water, so which it is neutralized with the 10% of NaOH, and cool and filter the yellow crystalline product on a Buchner funnel. wash it thoroughly with the water, and they recrystallize the product using the mixture of equal volume of rectified spirit and water, or from the hot water. What is the calculation of this synthesis? Here is the reagent acetanilide, and which is calculated amount molecular weight is 135 gram per mole, and p-nitroanil molecular weight is 138 gram per mole. Theoretical yield versus practical yield. What As we do always, percentage practical yield is equal to practical yield upon theoretical yield into 100. What is the conclusion? Whatever practical you performed and whatever yield you get after this calculation, you have to put it into the conclusion box, which is p-nitro and anilase was synthesized and percentage yield was found to be dash percentage. So here is the MSDS of chemicals which we have used in this synthesis. Glacial acetic acid on the concentrated and the concentrated HNO3 and concentrated H2SO4 are corrosive in nature. They may cause skin burns and irritation to skin, may cause serious eye damage and irritation of GIT upon ingestion. Acetanilide may cause the irritation to skin, eye. Upon ingestion, it causes the irritation to GIT. Inhalation may lead to irritation of respiratory tract and mucous membrane. Lengthy exposure may affect the ability of blood to carry oxygen, resulting in bluish discoloration of lips and tongues. Now, lab safety. We have to follow all the lab requirement and lab safety. Because there is a chances of incident of I mean yeah burns, and if we don't use the solution properly, then there is a chance of accident. So we have to follow all the lab safety requirements. Don't touch the animal, wear the safety goggles, wear the lab coats. It is really important to wear lab coat and gloves. And we shouldn't have to eat anything during the lab doing the synthesis of the procedure, or the mainly in the chemistry lab we should have to follow these rules very properly. So because we don't know what chemical does what effect in our body, so we should have to follow this. And then clean up your workspace after working. After your completion of your work, we should have to clean the workspace, whatever the space we conducted during our synthesis. So yeah, we should have to follow this lab safety requirement. It is really very necessary. Thank you guys for listening my video.